Hi, in this video I'm going to demonstrate a device I've just constructed to provide slew limit protection, or at least tracking protection, to Takahashi mounts. So what you can see here is a Takahashi NJP equatorial mount, which I use for imaging, and on the mount is a Takahashi TOA 130 refractor with the QSI 583 CCD camera. Please excuse the messiness of my garage. So the Takahashi NJP mount is great, excellent tracking, great performance for imaging, but the electronics are very crude. You can see the TEMA control box here on the front. The mount has no protection against tracking into itself. So I use automation software to do imaging overnight while I'm asleep, and as the telescope tracks, as it follows an object across the sky, it reaches a point where if it were to keep going, the camera or part of the telescope would collide. You can see the camera's about to touch the tripod. Now, to prevent that from happening, the mount has to perform a meridian flip. So it flips around. Let me unlock the deck axis here. The mount will flip around this way. I'm a little too close. Okay, pick up the target and follow it as it goes from the meridian to the western horizon, right? So my automation software is supposed to perform this meridian flip as the object crosses the meridian, but sometimes it doesn't. And if it doesn't and you don't catch it, the mount will collide. It'll just keep trying to go even though it can't because, for instance, the camera is hitting the tripod. And it'll just run all night long. The mount has clutches that will slip to protect the internal gearing, but you obviously don't want to rely on that. So here's my solution. In this box is a simple 3-axis accelerometer chip mounted to a breakout board, which you can purchase for about $15 from a website called Adafruit. 5 of the leads are attached to pins on this DB9 connector, and following a ribbon cable, we connect to an Arduino controller. Now on that Arduino controller there's an LED. The LED is currently there for testing purposes. It's going to be replaced with a connection to a device that allows me to control a 120 volt outlet. So you can see, let me move back a little bit. If the mount is not about to collide, the LED is on, indicating that the mount would have power. Everything would work as it's supposed to. As the mount keeps tracking past the meridian, the software should initiate a meridian flip. If it doesn't, and the mount keeps going, I'm going to keep moving the mount, you'll see the LED went off. The LED went off indicating that the power to the mount would have been turned off so that it can't collide with itself. Now, if the meridian flip actually happens on schedule, the way it should, you see the light is on. I'm moving the mount, moving the telescope so that the counterweight bar is, the telescope is now pointed at the meridian on the western side. You can see that as the telescope moves towards the horizon, the power to the mount stays on. The power to the mount only goes off if the telescope has tracked past the meridian, moving east, without flipping. I'm moving the mount. I'm moving it to where it shouldn't go. You can see the power goes off. I'm moving it back and forth. On, off. Okay, I hope you like this. I will post instructions and code as this project nears maturity, but I'm encouraged to see that it will work. Thanks.